Museums are increasingly using technology to reach outside their walls or to seek new ways to enhance their impact to the society and include more people. As technology and all its tools change, so do the challenges facing museums. Artificial intelligence of things is one of the next big concepts to have an impact in technology as we know it. The fast growth and use of IoT edge cloud continuum and of AI as a service is bound to be adopted for current and future technological needs. Just as interactive exhibits were introduced in museums to accommodate the educational needs and active desires of younger audiences, the usage of AIoT in traditional VR shows may draw in new audiences and make the technology even more adaptive to visitor and museum needs. The foundation of the Hellenic world being at the forefront of using technology and immersive experiences, provides at its Hellenic Cosmos Cultural Center a large variety of technologies and cultural experiences to public audiences and visitors. Its real-time, interactive dome codenamed Tholos, provides an impressive participatory immersive experience for large audiences with the benefit of using live human guides. The human guide navigates at real-time and controls what the dome will render, while at the same time commenting on the content being displayed. Even more immersive but for smaller groups are the location-based head-mounted display experiences that allow untethered, free roaming through a large room and collaborative experiences, as well as the usage of mainstream inside-out tracking head-mounted displays with limited space interactions for schools and larger groups. All experiences provided target the worldwide Hellenic culture and are created in-house, taking into account the educational curriculum of schools and universities. In such a versatile environment, the Foundation faces the challenge of maintenance, the cost of hosting adequate resources and the expansion of its services and technologies with newer ones. During the NEMO trials will be investigated how the usage of AIoT devices and the NEMO MetaOS framework can be used to enhance two VR experiences. The first trial will enhance the VR head-mounted display experience regarding the visit at an ancient Athenian workshop. In this experience, the user can navigate in the workshop of the famous artist Pheidias and help him complete the golden ivory statue of Zeus. As with many VR experiences, user monitoring is performed by visual observation of the station's TV screen and by judging the posture of the user. There is no other way to estimate if the player is uncomfortable or needs any other assistance. Therefore, the major goal of the first trial is to estimate the condition of the user and if needed notify the museum educator and alter the VR experience in order to assist him. This is the architectural diagram of the trial. The user will wear an HMD device. Anonymized user biometrics will be gathered from a smartwatch and communicated to a close-by Raspberry IoT Edge device. The data will be sent to an emotion recognition machine learning node located at the edge. If an emotion event is recognized, the message travels through a message broker and then in parallel to a data lake cloud node for training purposes and to an event server. The event server sends the event to all registered devices, which in our case will be the head-mounted display, in order to have the VR experience adapt, and to any external device such as a smart TV or phone to alert the museum educator. The data lake node will gather continuously all information and trigger an intent-based migration to a cloud-based high-performance computer in order to perform additional training on the recognition model if enough samples are acquired. The second trial will enhance a large-scale VR show in our real-time dome. As presented earlier, the experiences in the dome are based on live performances of a museum educator who controls the application, navigates, narrates and initiates games and quizzes for the visitors. All visitor interactions are performed using the For Visitor chair control buttons and with a joypad that is controlled by the presenter for the whole duration of 45 minutes, which is the regular length of a show. During that time, the visitors and staff outside the experience do not know at which state the show is, when it will finish or if there is a problem. Therefore, the major goal of the second trial is to provide gesture recognition to the museum educator to control the experience in a natural manner, without having to memorize which button of the joypad controls which function. Furthermore, gesture recognition will also provide the ability to the museum educator to inform external staff and visitors of the status of the show. This is the architectural diagram of the trial. The museum educator will perform as usual but will also be able to issue gestures to a camera that is mounted on a Jetson-based IoT Edge device. The video feed will be analyzed on a gesture recognition machine learning node located at the edge. If a gesture is recognized, the message will travel through a message broker and then send in parallel to a data lake cloud node for training purposes and to an event server. Any device registered to the event server will receive the message. In our case, the VR Dome computing cluster running the application will be notified to initiate actions and events inside the experience. A number of registered edge-based IoT Raspberry devices will also be notified to display the status of the experience on external screens. As in the previous trial, the data lake node will gather continuously all information and trigger an intent-based migration to a cloud-based high-performance computer in order to perform additional training on the recognition model if enough samples are acquired. The trial experiences will be validated on a controlled group of volunteers that will participate in the scenarios from different role types such as system administrators, application owners, presenters, and visitors. Feedback will be collected using questionnaires that are going to be filled out after each use case scenario. It is our belief that NEMO will bring intelligence closer to the data and make the AI as a service model an integral part in more alternative areas such as culture and heritage.